Hi there and welcome to the Air Equipment LLC YouTube channel. This is part 2 of our discussion of life safety dampers. Let's talk a little bit about smoke dampers. Smoke dampers are designed to block the passage of smoke, and there are various leakage classes that the dampers are rated for. Leakage class 1 is the best, and that will allow only 8 CFM of air to pass by at 4 inches of pressure, which is a fair amount of pressure. And then there's leakage class 2 and 3, which allow for more passage of smoke and air through there. I don't think I've ever seen a leakage class 3 damper specified, and by far most common we see leakage class 1, understandably. And it doesn't really cost much more to get those extra tight seals on the blades of those smoke dampers. So leakage class 1 is really the one you should always specify. The dampers also are rated for air velocity, and the minimum rating is 2,000 feet per minute at 4 inches of pressure. You can get higher ratings than that if necessary. And the temperature rating for the smoke dampers are either 250 degrees or 350 degrees. A smoke damper designed to block the passage of smoke through a rated partition can be installed within 24 inches of that partition. This is a little different than what we see with fire dampers. Fire dampers usually need to be installed right in the plane of the wall or ceiling or floor that they are protecting. However, with smoke dampers, they can be installed up to 24 inches away and still be valid, still be completely proper. The big thing is, though, there can be nothing in the duct or connected to the duct between the damper and the wall. In other words, no branch takeoffs in that space between the damper and the wall, no access doors, no registers or diffusers. So it has to just be a solid, straight, unbroken piece of ductwork between the damper and the wall. The UL 555S testing to get rated to be a valid smoke damper is pretty stringent. If the damper is designed to be two-position, just open or close, it must be cycle tested 20,000 times. Has to successfully complete 20,000 cycles in order to pass the test. Now, if the damper is one of the new style modulating smoke dampers, where it has a modulating actuator that allows it to operate as a control damper, in addition to being a smoke damper, that product has to be cycle tested 100,000 times in order to pass the test. So when these dampers are manufactured and shipped and installed, you know that they're going to work because they've passed really, really tough testing. The dampers have to be tested with elevated temperatures, rated for either 250 degrees Fahrenheit or 350. And the dampers have the leakage rating we just discussed earlier. At class 1 is by far the best, allowing only 8 CFM of air or smoke to pass through at 4 inches of pressure. Now, quite often today, partitions within buildings are rated for both fire and smoke. Now, you could install 2 separate products. You could install a fire damper in the plane of the wall and then a smoke damper within 24 inches of that. But why install 2 separate products when you can install one combination product? And the combination fire smoke damper is designed to stop both the passage of flame, that's the fire damper function, and designed to stop the passage of smoke, the smoke damper function. Just like a smoke damper, it is motor operated. Those actuator motors for life safety dampers must be power open, fail, spring return, close. So they're always energized, cranking the blades in the open position during normal operation of the building. If there is a fire detected within the building, a signal is sent, it cuts off the power to the actuator motor, and the internal spring cranks the blades closed. Even though the life safety dampers are part of the HVAC system within a building, technically they are not part of the ductwork. They are part of the partition that they are designed to protect. So when we install a fire or a combination fire smoke damper in a wall, it is securely attached to that wall and it needs to stay in place. Even if there's a disaster with the building, say on one side of the wall the roof collapses, that damper must stay in place. If the roof collapsed onto the ductwork and yanked that damper out of the wall, now that wall would not be protected. There would be a big opening there where flame and smoke could pass through to the other side, and that violates our whole concept of compartmentalization. So the damper must stay in place. It must stay connected to the partition it is protecting. So to make sure that happens, we have what are called breakaway connections. The ductwork connected to the damper sleeve must be able to break away if something collapses onto it and still leave the damper in place in the wall. And there is an actual UL rated duct impact test where a damper and its sleeve are installed in a wall. They make a mock-up, build a mock-up wall, install a damper in it, have ductwork connected to that damper sleeve, and then they take a 55-gallon drum and fill it with sand to the prescribed weight. They raise it up a certain distance above the ductwork, and then they drop it. And it slams down on that duct, and that duct must break away from the damper sleeve. And then after the test is done, that's only the first half of the test, then they have to inspect the damper and make sure that it still is within the plane of the wall and that it operates. They have to cycle it to make sure it does close. So it's a very, very tough test to make sure that that damper and sleeve assembly stays in place in the wall and the ductwork connected to it breaks away and doesn't yank it out of the wall. There are a number of different methods to connect the ductwork to the damper sleeve using various types of flanges or even a TDC or TDF flange material where the ductwork is actually fabricated with a flange on it in the shop. And these have all been tested, and it used to be much more difficult to find the right connections, but so many of them now have been tested and approved that virtually any type of connection, whether it's ward or duct main on one side and TDC or Nexus on the other side, they have been tested and are approved as valid breakaway connections.